Okay, now let's see how we can modify some sections of this code as well as deploy and run this code in a virtual environment. Suppose that we need to alter the data type of this particular balance. Maybe I want to use unsigned integer 16. So if you see here, when you just type it over here, recommendations will come, you can use that. So when I give that unsigned integer 16, so what is happening over here? See, the many errors are showing. Type error is showing in line number 13. So what is the issue? Because the parameter is unsigned integer 256, it is being added with unsigned integer 16. So it will be giving a 256 bit value. So it won't be compatible. So I will be changing this to unsigned integer 16 to. Similarly, I will change all other assignments, then only it will properly work. This is being dynamically compiled and errors are captured because we have set as auto compile, right? So auto compilation is happening. Then here the return type is also unsigned integer 16, right? Because our balance is updated to unsigned integer 16. So now it is a green check mark. It means that it compiled without any issues. Now we need to deploy it. So go to the deployment section and then you have to choose the environment. So we are actually going to use a virtual environment. So Remix virtual machine, the virtual machine powered by Remix, it is going to be used. Now, the another major thing you have to note here is for testing our contract and to run our contract within virtual machine, we know that gas is required, right? So even if this is a virtual blockchain, concept of gas is actually implemented. So for us, by default, Remix gives us so many accounts populated with fake ether. Okay, so one such account is given at the top, it has 100 ether with it. So we can use it for our testing and debugging purpose. Okay. Now the contract name is also shown. Now only thing is we need to deploy the contract. So I'm clicking on the deploy button. So it means that it is being deployed into the fake or the virtual blockchain hosted within this web browser. Okay, so as I told you, deployment is a transaction. It is initiated by EOA or our account. So if you see here, earlier it was 100 ETH, but now it's only 99.99 because we initiated a transaction to deploy this contract in the fake blockchain, right, or a simulated blockchain. So that transaction details is shown over here. As I told you, if you click on this one, formatted output similar to Etherscan will be shown. So if you see here, what is happening from this particular account, right? This accounts public address is given. If you see here, it matches. We are actually deploying the contract, right? The transaction cost, execution cost, everything will be shown here. So for each of the operations that you do over here, transaction hash will be generated or the log will be generated for this particular simulator. So it will be easy for us to debug. Okay, so once you click deploy, apart from log being generated, actual deployment is happening in this virtual blockchain. So what you see here is that deployed contracts will be listed at the bottom. Click on deployed contracts. So if you see here, what are the functions we defined? Deposit, withdraw, and view balance. So deposit, withdraw, and view balance functions are shown over here. So if I click on this deposit button, the parameter that I pass over here, it will be supplied to this deposit function and this function will execute. Okay, so the data type is also shown by default. Similarly for withdraw also, its logic will be triggered once I supply it with the parameter and click on this withdraw button. Then if you see the case of view balance, it doesn't take any parameter as input. That is why no boxes are shown. Then as I told you, we actually define this balance as a public state variable. So by default in Solidity, all public state variables will have its default getter function. So this balance, if I click, it will show me the current balance. Okay, so this contract is deployed, right? So it means that this constructor has run balance is set as 0. So if I just query this getter, which was created due to deployment, it will show the value as 0. See, that transaction is shown, a call was initiated, that is shown, right? The further details of the call is also there, just like Etherscan. Now, I actually use the default getter function. If I want to use our define function, I will click on view balance. So it also returns similar value, 0. Now, suppose I want to add some amount to this particular bank account so that the balance is updated. So note that it has to be within 16 bits. So maybe I'll give some 10 value and I will deposit it. So this transaction has gone through. If I see the details of the transaction, gas cost and everything will be there. Then what was the input given? Decoded input. See, the input that I gave was an unsigned integer 16. The value was 10. Okay, so these things happened. Everything is shown over here. Now, when I click on view balance, now it is showing me the updated balance. The corresponding transaction happening in the virtual blockchain is shown over here. Now, if you go to the section above, you can see the ether balance getting updated in our virtual account because all these cost gas in the actual blockchain. So that is being simulated. Okay, now I need to withdraw some amount. So maybe I will give values to, I give withdraw. So the withdraw operation is happening. So the input is 2 and all other operations are listed over here. Then once I check the balance, it will be properly reflecting. So this is how you can locally debug your smart contract virtual blockchain provided within the browser.